At 10:17 a.m. on February 1st, 1943, a photographer at Biskra airfield in Algeria snapped one of the most chemically impossible images of World War II. It shows a B-17F Flying Fortress, tail number 124406, sitting on the desert hardpack. The fuselage is not just damaged, it is nearly severed. A massive, jagged diagonal gash slices through the aluminum skin, leaving a 16-foot gap of daylight where the aircraft's structure should be. Looking at the photo, your brain tells you this is a wreck that was dragged out of a crater. Your brain is wrong. This aircraft, the All-American, had just landed. It had taxied off the runway, engines idling, with 10 men alive inside. By every calculation of drag, weight distribution, and structural load known to Boeing engineers in 1943, the tail section should have snapped off the moment the aircraft banked. To understand how a 30-ton bomber defied the laws of aerodynamics for 90 minutes, we have to go back to the exact second the laws of physics were suspended. 9:14 a.m. over the Tunisian coast. A Messerschmitt Bf 109, piloted by German ace Erich Paccia, is diving out of the sun. Hess dead at the controls, his fighter is inverted, and he is closing on the All-American at 600 miles per hour, directly into the fuselage. The impact didn't sound like a bomb going off. It sounded like a structural scream, a deafening metallic shriek that vibrated through the seat springs of every man aboard. The Messerschmitt didn't just strike the All-American. It passed through it. The German fighter's wing acted as a hardened steel guillotine, slicing diagonally through the rear fuselage of the B-17 just forward of the horizontal stabilizer. In the cockpit, First Lieutenant Kendrick Bragg was thrown forward against his harness restraints. The violence of the collision pitched the nose of the 30-ton bomber upward, a sudden, sickening lurch that pinned the crew to their seats with G-force. Bragg's hands were already moving before his brain processed the collision, his instincts screaming to regain level flight. He gripped the control yoke, the heavy, U-shaped wheel that commanded the ailerons and elevators, and shoved it forward to arrest the climb. It should have been a heavy, resistant push. A B-17, at 200 miles per hour, requires significant muscle to maneuver. The airflow over the massive control surfaces fights back against the pilot's inputs. But when Bragg pushed the column, it didn't fight back. It slammed forward against the instrument panel with a hollow clatter. It was weightless, slack. "I've got no elevator," Bragg shouted over the intercom, dragging the yoke back into his stomach. The column slid freely in his hands, completely disconnected from the aircraft. He slammed his boots onto the rudder pedals to correct the yaw, but the pedals flopped loosely against the floorboards. The aircraft was no longer flying. It was ballistic. The nose dropped heavily, and the All-American began a slow, terrifying roll to the left, banking toward the hard Tunisian desert 9,000 feet below. To understand why this was a death sentence, you have to look beneath the aluminum skin of a 1,940 seconds heavy bomber. Today's jetliners fly by wire electrical signals sent to hydraulic computers. But the B-17 Flying Fortress was a mechanical beast. It was flown by muscle and steel cable. Running along the floor of the fuselage, hidden beneath the narrow catwalk used by the crew, were bundles of braided steel cables, each about the thickness of a pencil. These were the nervous system of the aircraft. When Bragg turned the wheel in the cockpit, he was physically pulling a cable that ran 60 feet down the length of the plane, through a series of pulleys and tensioners, to manually heave the giant rudder and elevator surfaces at the tail. The Messerschmitt had severed that nervous system. The German fighter's wing had slashed through the top of the fuselage and exited through the bottom, cutting a clean path through the dorsal longerons, and critically, shearing the entire bundle of control cables. The connection between the pilot's hands and the aircraft's tail was gone. Bragg wasn't flying the plane anymore. He was just sitting in the front seat of a falling building. Behind the cockpit, the situation was visually apocalyptic. The navigator, Harry Nunez, looked back through the bomb bay and saw something that made no sense. He wasn't looking at the interior of a fuselage. He was looking at the sky. The tail section of the bomber was swaying independently of the main cabin, twisting and grinding in the 200 mile-per-hour slipstream. The left horizontal stabilizer, the mini-wing at the tail that keeps the plane from flipping nose over, was completely gone, ripped off at the root. The vertical stabilizer, the tail fin, was canted at a sickening angle, and the fuselage itself held together by a miracle. The B-17 is built with Z-frame ribs and heavy aluminum stringers running lengthwise to provide rigidity. The collision had sliced through almost all of them. The entire tail section, housing the rear gunner and the crucial rudder surfaces, was hanging on by a shred of metal on the bottom right side and the single dorsal longeron, the metal spine running along the top of the aircraft. "Pilot, this is waste," the voice crackled over the intercom, static-filled and panicked. "The tail it's hanging off, sir. I can see daylight through the side." Bragg ignored the report. He was fighting the roll. The B-17 wanted to spiral. Without the left horizontal stabilizer, the lift was asymmetric. The right side of the tail was generating lift. The left side was generating nothing but drag and turbulence. This imbalance was twisting the fuselage, threatening to snap the fragile spine, holding the ship together. If they entered a spin, the centrifugal force would rip the tail off instantly, and the forward section would tumble all the way to the ground. Bragg grabbed the throttles. He couldn't steer with the rudder, so he had to steer with power. He shoved the throttles for the number 3 and 4 engines, the ones on the right wing, forward, while pulling back on 1 and 2. The burst of power on the right forced the wing up, countering the roll. The huge radial engines roared in protest, but the nose leveled out. "Steady," Bragg muttered, sweat stinging his eyes. "Hold it." He had stopped the roll, but they were still descending. The aircraft was nose-heavy and wanted to dive. Instinctively, Bragg reached for the elevator trim wheel, a smaller wheel on the side of his seat used to fine-tune the aircraft's pitch. He spun it frantically. Nothing. The trim tab cables ran through the same bundle as the main control cables. They were severed too. They were losing altitude. 8,500 feet. 8,000 feet. The desert floor was rising to meet them. Bragg looked at his co-pilot, Godfrey Engel. Engel's face was pale, his eyes locked on the altimeter unwinding. There was a shared, silent realization in the cockpit. They couldn't bail out. If the pilots left their seats to strap on parachutes, the plane would instantly spiral, trapping the rest of the crew inside the fuselage as centrifugal force pinned them to the walls. But they couldn't land either. You cannot land a 30-ton bomber without elevators to pull the nose up. If they hit the ground in this dive, the nose wheel would dig into the sand, and the aircraft would cartwheel, shattering into a fireball. They were trapped in a paradox. They were flying a dead machine that required constant, aggressive management just to keep it from flipping over. Yet they had no means to manage it. The yoke was dead. The pedals were dead. The trim was dead. "Lieutenant," Engel said, his voice surprisingly calm amidst the roar of the engines. "We're going to hit." Bragg scanned the instrument panel, looking for anything, any system, any backup, any lever that might still connect the front of the plane to the back. His eyes swept over the fuel gauges, the oil pressure, the radio compass. Useless. Then, his gaze landed on the center console, between the two pilot seats. There, sitting innocuous and mostly ignored during combat maneuvers, was the control head for the C-1 autopilot. It was a box of dials and switches, connected to the Norden bomb site. It wasn't designed for flying a crippled plane. It was designed to keep the aircraft perfectly steady for the 20 seconds a bombardier needed to line up a target. It didn't use the mechanical cables running along the floor. It used electrical servos, small motors mounted directly in the tail to move the control surfaces. If the wires running to those electrical motors were still intact, if that single bundle of copper had somehow survived the steel guillotine that severed the cables, they might have a ghost of a chance. But Bragg couldn't operate it from the pilot's seat. The brain of the system wasn't in the cockpit. It was in the glass nose of the aircraft, under the fingertips of the bombardier. That glass nose, exposed and fragile at the very front of the bomber, had suddenly become the only cockpit that mattered. While Bragg wrestled with the dead yoke in the flight deck, Bombardier Ralph Burbridge was crouched over the Norden bomb site in the nose compartment, unaware that he was about to become the pilot of a 30-ton aircraft. "Burbridge," Bragg's voice cracked over the interphone, cutting through the slipstream roaring through the shattered fuselage. "Engage the C-1. Engage the autopilot." Burbridge froze. Using the autopilot in a damaged aircraft was technically forbidden by Army Air Force's flight manuals. The Minneapolis Honeywell C-1 autopilot was a sensitive, temperamental instrument. It used a system of gyroscopes to sense the aircraft's attitude and sent electrical impulses to servo motors. Small, coffee can, sized electric engines connected to the control surfaces with short chains. It was designed to hold the bomber straight and level for the final 20 seconds of a bomb run, providing a stable platform for the drop. It was not designed to wrestle a structurally compromised airframe through turbulence for 90 minutes. If the gyros tumbled or the servos fought the twisted fuselage too hard, they could snap the control cables entirely or burn out the motors. But Bragg had no choice. The mechanical linkage was gone. The electrical linkage was the only prayer left. Burbridge reached for the autopilot clutch handle on the side of the bomb site stabilizer. He pulled it. Deep in the tail section, past the 16-foot gash where the fuselage was nearly severed, a small electrical servo motor hummed to life. Unlike the thick steel cables that had been sheared by the Messerschmitt, the electrical wiring for the autopilot servos ran along the fuselage roof, woven into a different harness. By a stroke of geometric luck, the German fighter's wing had missed this specific bundle of wires by inches. The servo motor received the signal. It spun its internal gear, pulling a short chain connected directly to the rudder horn. In the cockpit, Bragg felt the aircraft shudder. The nose, which had been dipping toward the desert, jerked upward. It wasn't the smooth, fluid motion of a pilot pulling back on the stick. It was a mechanical, robotic correction. The C-1 sensed the nose drop, calculated the error, and aggressively trimmed the elevator to compensate. It's catching. Engel breathed, watching the artificial horizon, its holding level. But the All-American wasn't safe. It was simply in a new kind of danger. The C-1 autopilot was a bang-bang system. It corrected errors with sharp, distinct inputs. In a normal B-17, this was fine. In a B-17 held together by a single dorsal longeron and a shred of aluminum skin, these sharp corrections were lethal. Every time the servo kicked the rudder or elevator, a shockwave of stress traveled through the broken fuselage. Bragg realized instantly that he couldn't just leave the autopilot on and sit back. The system was fighting the drag from the missing stabilizer. If it corrected too hard, it would twist the tail right off the plane. He needed to dampen the system, to smooth out the robot's inputs. Burbridge, Bragg called out, his voice dropping to a focused, surgical calm. I have no control up here. I need you to fly her from the nose. Use the PDI knobs. Make your input small. If you jerk her, she breaks. This was the heretical solution. The pilot direction indicator, PDI, was a secondary interface used by the bombardier to make minute adjustments to the flight path during the bomb run. By turning the small knobs on the stabilizer unit, Burbridge could override the gyros and command the servos directly. Effectively, the command hierarchy of the B-17 had just inverted. Bragg, the commissioned officer and pilot, was now a passenger with a view. He gingerly twisted the turn compensation knob. The huge bomber banked slowly. It felt sluggish, heavy, like driving a tank through deep mud. The servo motors whined audibly, struggling against the chaotic airflow swirling around the damaged tail. Every correction was a gamble. Burbridge had to anticipate the wind gusts. If a gust hit the tail and the autopilot tried to fight it instantly, the opposing forces, the wind pushing one way, the servo pushing the other, would create a shearing force directly on the fracture point. Bragg sat with his hands hovering over the dead yoke, his feet light on the dead pedals, ghosting the movements. He watched the cylinder head temperatures on the right wing. They were climbing. To keep the plane level with all that drag on the tail, the autopilot was commanding a nose-up attitude, which slowed the airspeed. To prevent a stall, Bragg had to run the engines at nearly full power. They were flying a dirty airplane, aerodynamically crippled, using a delicate instrument for brute force labor. Watch your cylinder temps, pilot, the engineer called out from the top turret. Number 3 is running hot. We're pushing it too hard. We don't have a choice, Bragg replied. Burbridge, keep that turn shallow. Don't go past 15 degrees of bank. The All-American droned on, a zombie aircraft guided by a bombardier's fingertips. But the true horror of their situation wasn't in the cockpit or the nose, it was in the tail. While Burbridge turned the knobs and Bragg managed the throttles, they were all unknowingly conspiring against one man. Tail gunner Sam Sarpoulos was still at his station, and he was about to discover that the laws of physics had drafted him for a job far worse than shooting down fighters. He was no longer just a gunner, he was the only thing keeping the plane from snapping in half. Sam Sarpoulos was not just a gunner anymore. He was a solitary tenant in a metal island drifting 9,000 feet above the Sahara. Separated from the rest of the crew by that 16-foot slash in the fuselage, he was effectively riding in a glider towed by the main bomber, connected only by a few twisted strips of aluminum and the floor beam. A popular, sanitized version of this story exists. You might have heard it or seen it in dramatizations. In that version, the heroic crew fashions a lifeline from parachute cords. They toss it across the gaping hole to Sarpolis, and with the swelling music of a Hollywood score, the tail gunner swings across the abyss like an acrobat, pulled into the waiting arms of his brothers. It is a comforting image. It speaks to the American ethos of no man left behind. It is also a lie that insults the terrifying intelligence of the decision Bragg and his crew actually had to make. There was no rope rescue because physics is not sentimental. The moment Navigator Nunez and Engineer Joe James looked at the damage, they understood the brutal mathematics of the lever arm. An aircraft in flight is a teeter-totter balanced on its wings, the center of gravity, or CG. The tail section acts as the long end of the lever. Because the lever is so long, even a small amount of weight at the tail exerts massive torque on the fulcrum. Sarpolis, in his flight gear, weighed perhaps 170 pounds, but 30 feet behind the wings, that 170 pounds was exerting thousands of foot-pounds of force on the airframe. Right now, the B-17 was in a precarious, miraculous equilibrium. The autopilot was trimmed to handle the aircraft exactly as it was loaded. The lift from the wings, the drag from the shattered tail, and the weight of the gunner were perfectly fragility balanced. If Sarpolis tried to cross the gap, he wouldn't just be risking a fall. He would be shifting the center of gravity. If he moved forward, the tail would become lighter. The nose would drop. The C-1 autopilot, sensing the pitch change, would command the elevators to pitch up. The servos would snap the control surfaces. That sudden, violent correction the jerk Bragg was so afraid of would transmit a shockwave of torque through the dorsal longeron. The spine would snap, the tail would tear free, and the All-American would tumble. The crew realized the sickening truth. Sarpolis was the ballast. He was the human counterweight keeping the broken machine stable. For the pilot and the bombardier to save the ship, the gunner had to stay exactly where he was. Stay put, Sam. The order was relayed, likely through hand signals across the roaring gap since the interphone wires to the tail were severed. Don't move. Sarpolis, freezing in the slipstream, looked across the chasm. He could see his friends in the waist section. He could see the jagged teeth of the torn aluminum. He could see the desert floor rushing by through the hole in the floor. He knew that if the tail broke off, he would spin to earth in a metal coffin, unable to bail out because the G-forces of a tumbling tail section would pin him to the wall until impact. He gave a thumbs up. He understood. He sat back on his small canvas stool, his hands gripping the breeches of his twin, 50 caliber machine guns. He wasn't just a passenger. He was an active component of the airframe's integrity. He had to keep his body weight centered, minimizing vibration. And the vibration was getting worse. As the All-American limped away from the coast, the adrenaline of the collision began to fade, replaced by the gnawing, mechanical dread of material fatigue. Metal has a memory. Every time the aluminum bent, every time the tail swayed in the wind, the crystalline structure of the remaining alloys was hardening, cracking, weakening. From the waist gunner's position, Sergeant Michael Zook watched the tail section with morbid fascination. It wasn't rigid. It was breathing. With every gust of wind, the entire rear of the plane, the vertical fin, the rudder, the gunner's compartment would twist. It would rotate 5 degrees to the left, then 5 degrees to the right. The fuselage skin would buckle and pop, the sound like pistol shots cracking over the engine roar. "Shay's wobbly, Lieutenant," Zook yelled forward. "The whole tail is oscillating." This was aeroelastic flutter, the same phenomenon that tears bridges apart in high winds. The damaged structure had lost its stiffness. The airflow was grabbing the tail and shaking it like a dog shakes a rat. Bragg, gripping the dead yoke, could feel the phantom vibrations through the floorboards. "Burbridge, ease up on the inputs. She's twisting." "I'm barely touching it, Bragg," Burbridge shouted back from the nose. "The air is doing it." They were trapped in a torture chamber of aerodynamics. To get home, they had to fly fast enough to prevent a stall. But speed is energy. The faster they flew, the more violent the airflow became, and the more the tail shook. They had to find the exact speed, the corner velocity where the wing generated enough lift to stay airborne, but the airflow was slow enough not to rip the tail off. Bragg scanned his airspeed indicator. 140 miles per hour. Too fast. The vibration was rattling the instrument panel. Bringing her back, Bragg announced. He eased the throttles back. The roar of the right cyclones deepened. The airspeed needle dropped. 135, 130, 125. At 120 miles per hour, the violent shaking smoothed out into a menacing shudder. The tail was still twisting, but it wasn't thrashing. Holding 120, Bragg said. But 120 miles per hour was dangerously close to stall speed for a B-17 with a damaged wing and a load of fuel. And they were still losing altitude, 7,000 feet now. The mountains of Tunisia were behind them, but the vast, empty hardpan of the desert lay ahead. And then, the physics of the broken plane delivered its next ultimatum. The number one engine, the outboard engine on the left wing, coughed. A puff of black smoke whipped past the cockpit window. The oil pressure gauge flickered and dropped to 0. The engine wasn't damaged by the collision. It was dying from the strain. For 30 minutes, Bragg had been running the engines at high power to keep the draggy, dirty airframe in the sky. The number one engine, fighting the asymmetric drag of the missing tail stabilizer, had simply given up. "Feathering number one," Bragg shouted. He hit the red feathering button. The propeller blades twisted into the wind to reduce drag, and the engine ground to a halt. Now they were down to 3 engines. And because the dead engine was on the left, the same side as the missing horizontal stabilizer, the aircraft yawed violently to the left. The nose swung hard, threatening to put them into the spin Bragg had been fighting since the impact. Normally, a pilot would stomp on the right rudder to counter the yaw. Bragg didn't have a rudder pedal. He had Burbridge and his little knob in the nose. "Right turn, correct right," Bragg yelled. But Burbridge couldn't correct fast enough. The plane was skewing sideways, flying crabwise through the air. The fuselage groaned under the new torsional stress. The single dorsal longeron, the spine holding Sarpolis, and the tail to the rest of the ship, screamed. The single dorsal longeron screamed. It wasn't a metaphor. It was the physical sound of the aircraft's aluminum spine stretching beyond its yield point. With the number one engine dead and feathering, the All-American was no longer flying straight. It was crabbing, slewing sideways through the air like a car skidding on ice. The massive drag from the dead propeller on the left wing acted like an anchor, violently pulling the nose to the left. Normally, a pilot would counter this with a heavy boot on the right rudder pedal, but Bragg's pedals were disconnected. He was trying to fly a 30-ton asymmetric glider with a remote control. "Burbridge, max right turn. Give me everything," Bragg roared. In the nose, Burbridge twisted the autopilot knob to the stops. The servos in the tail whined, forcing the rudder over. But it wasn't enough. The drag was too strong. The nose kept swinging left. If they turned broadside to the wind, the slipstream would hit the 16-foot gash from the side, catching the torn fuselage like a sail and ripping the tail section clean off. Bragg had one card left to play: differential thrust. He grabbed the throttle levers. He jammed the number 2 engine, the only surviving engine on the left wing, forward to the firewall. The manifold pressure gauge spiked. The engine screamed, delivering maximum horsepower to pull the left wing forward. Simultaneously, he pulled back the throttles for engines 3 and 4 on the right. The sudden shift in power kicked the aircraft. The nose swung back to the right, shuddering as the thrust fought the drag. "Chaise, straightening," Engel yelled. "Heading is stabilizing." They were flying, but the cost was terrifying. To keep the plane straight, Bragg had to torture the number 2 engine, running it at emergency war power, while the right engines were idling. They were bleeding energy. The altimeter began to unwind faster. 6,000 feet, 5,000, 500, and the structural clock was ticking. What Bragg and his crew were experiencing was a masterclass in Boeing's fail-safe engineering philosophy, pushed to its absolute breaking point. The B-17 was not built like a modern airliner, which uses a semi-monocoque design where the outer skin carries much of the load. The Fortress was a dinosaur of the 1,930 seconds, built like a bridge. It relied on heavy Z-section frames, circular ribs that formed the shape of the fuselage, and thick aluminum longerons running the length of the ship. The collision had severed all the bottom longerons. It had severed the side stringers. The only thing holding the tail section to the main cabin was the dorsal longeron, a single, C-shaped beam running along the very top of the roof and a narrow strip of skin on the right side. Every time the plane hit turbulence, that single beam had to absorb the entire bending moment of the tail. It was taking tension loads it was never designed for. From the waist window, Sergeant Zook watched that beam. He saw rivets popping. Pop, pop, pop. Small silver heads sheared off and whipped away in the wind. The skin around the gash was wrinkling, stretching taut like fabric, then buckling as the tail bounced. "Chaise tearing, sir," Zook reported, his voice tight. "The skin is unzipping on the right side." "How much is left?" Bragg asked. "Maybe 5 inches of skin. And the top beam. That's it." They were 90 miles from Biskra. 90 minutes of flight time at this reduced speed. The rest of the formation had long since pulled ahead, their silver shapes disappearing into the haze. Standard operating procedure dictated that the group could not slow down for a straggler in hostile territory. The All-American was alone. The isolation was total. No radio. No escort. Just the deafening wind howling through the hole in the floor and the vibration. That vibration became the rhythm of their survival. It wasn't a steady hum. It was a rhythmic thrum, thrum, thrum that shook the control columns and rattled the teeth of the men. It was the aerodynamic resonance of the severed tail twisting in the slipstream. Bragg found himself in a trance of hyper-focus. He couldn't make sudden movements. He couldn't fly by feel, because the yoke felt nothing. He had to fly by numbers. Keep the airspeed above 120 stall speed. Keep it below 140 structural failure. Watch the cylinder head temperature on the number 2 engine. If that engine failed, they would yaw uncontrollably and snap the tail, 4,000 feet. Engel called out. The desert floor was becoming distinct. They could see the individual rocks, the scrub brush, the shadows of dunes. They were trading altitude for time. We're not going to have enough height for a pattern. Bragg said, doing the mental math. We're going to have to go straight in. If we can find the field, Engel replied. The heat haze off the desert was blurring the horizon. Without a navigator's compass, Nunez's instruments were shaking too badly to read accurately. They were steering by dead reckoning and memory. Then, a new sound cut through the roar. A high-pitched snap, followed by the whip crack of loose metal. The top turret, James yelled. The fairing just blew off. The vibration was shaking the aircraft apart, piece by piece. The aerodynamic fairing behind the top turret had rattled loose and torn away. The All-American was shedding weight, but not in the way they wanted. Hold it together, Bragg whispered to the dashboard, his knuckles white on the useless yoke. Just hold it together. They were flying a dying animal. The airframe was groaning, a low-frequency moan that was audible even over the engines. It was the sound of aluminum fatigued to the molecular level. Field in sight, Nunez shouted from the nose. 11 o'clock! 10 miles! Biskra Airfield. A patch of flat sand with a windsock. It looked like salvation. But as Bragg looked at the runway, the realization hit him. Taking off is optional, landing is mandatory. And landing a tail-dragger aircraft requires you to flare to pull the nose up and let the tail wheel settle gently. But they had no elevator control to pull the nose up. And they had no tail wheel. The tail wheel mechanism was part of the structure that was currently hanging by a thread. If they touched down normally, the shock would snap the longeron, the tail would break off, and the fuselage would plow into the sand at 100 miles per hour. Bragg looked at Engel. We can't do a 3-point landing. The tail will snap. So we bail out? Engel asked. Bragg looked back at the gap, at Sarpolis trapped in the tail. If they bailed out, the plane would crash, and Sarpolis would die. No, Bragg said. We land on the mains, and we keep the tail in the air. Until when? Until we stop. It was an impossible plan. He intended to land a B-17, like a wheelbarrow, balancing on the front 2 wheels, holding the broken tail off the ground with aerodynamic lift until the speed dropped to 0. It required delicate pitch control, something they didn't have. They were 5 miles out, 2,000 feet. The final test of the single longeron was about to begin. The single dorsal longeron had survived the air, but the ground was a different enemy. As Biskra Airfield expanded in the windscreen, filling the plexiglass with the brown and yellow of the Algerian desert, Bragg knew that the final test of the All-American spine wasn't about aerodynamics. It was about impact. Gear down, Bragg ordered, his voice flat. Co-pilot Engel reached for the lever. This was the moment of truth for the fuselage. The B-17's main landing gear are massive struts that extend from the engine nacelles, but the shock of their locking mechanism sends a shudder through the entire airframe. Engel threw the switch. The electric motors whined. Two heavy thuds echoed through the ship as the main wheels locked into place. Thump, thump, the aircraft groaned. The tail section whipped vertically up, then down, flexing on its hinge of torn aluminum. For a heartbeat, the crew waited for the snap. It didn't come. The longeron held. Gear down and locked. Engel breathed. Below them, the airfield had erupted into chaos. Ground crews, alerted by the radio silence and the visual of the mutilated bomber, were sprinting away from the runway. A red flare arched up from the control tower, the universal signal for emergency. Ambulance and fire trucks stand by. They could see the damage clearly from the ground now, a flying wreck that looked like it had been chewed by a giant steel maw. "Burbridge," Bragg said, staring at the rushing earth. "Do not flare. Do not try to stall her in. We fly her onto the ground. Keep the nose level." "Copy," Burbridge replied from the nose. His hand was trembling over the autopilot pitch knob. Standard procedure for landing a tail-dragger aircraft like the B-17 is a three-point landing. The pilot pulls back on the yoke just above the runway, stalling the wings so the main wheels and the tail wheel touch down simultaneously. It's smooth, it's safe, and for the All-American, it would be fatal. If they did a three-point landing, the tail wheel would hit the dirt. The impact would drive the tail upward, shearing the dorsal longeron instantly. The fuselage would snap in two, and the rear section with Sarpolis inside would tumble across the desert at 100 miles per hour. Bragg had to perform a wheel landing. He had to touch the main wheels down while keeping the tail flying high in the air, balanced on the slipstream, until the aircraft slowed enough that the inevitable collapse wouldn't kill them. 110 miles per hour. Engel called out. 100 feet. The desert floor blurred beneath them. The heat shimmer made the runway dance. Bragg made micro-adjustments to the throttles, walking the heavy bomber down an invisible staircase. He couldn't feel the plane, so he had to fly by sight picture alone. 50 feet. Speed 105. The ground effect, the cushion of compressed air that builds up between the wings and the runway, pushed back against them. The All-American wanted to float. Normally, Bragg would push the yoke forward to pin it down. He couldn't. "Nose down, Burbridge. Just a hair. Trimming down." The servos whined. The nose dipped. Screech. Blue smoke exploded from the main tires as they kissed the hardpack. The All-American shuddered, but Bragg didn't cut the power. Not yet. If he cut the throttles now, the loss of prop wash over the tail would kill the lift and the tail would slam down. "We're rolling." Bragg yelled. "Keep that tail up, Burbridge." Fly the tail. They were careening down the runway at 90 miles per hour, tail high, looking like a sprinter leaning forward. Bragg gently, agonizingly slowly, retarded the throttles. The roar of the right cyclones faded, replaced by the rumble of tires on dirt and the terrifying sound of the wind howling through the fuselage gap. 80 miles per hour. Engel counted down. This was the critical window. As speed decreased, lift vanished. The tail section was getting heavier by the second. Gravity was clawing at Sarpolis, trying to drag him into the dirt. 70 miles per hour. Bragg could see the horizon rising. The tail was sinking. He had no way to stop it. The autopilot had run out of authority. At this speed, the air over the small stabilizers was too slow to generate the force needed to hold up the heavy rear section. "Shay's dropping," Zook yelled from the waist. "Hold on," Bragg shouted. At 50 miles per hour, the physics of flight finally surrendered. The lift evaporated. The tail section, weighing over 1,000 pounds, succumbed to gravity. It dropped. There was no tail wheel to catch it. The structure had been compromised. Crunch. The sound was sickening, a grinding, tearing scream of metal on stone. The tail section impacted the runway. The friction acted like an anchor. The drag was instantaneous and violent. The All-American slewed to the right, skidding through the dirt. Dust billowed up through the hole in the floor, choking the crew. The sound of rivets shearing was like machine gun fire. The dorsal longeron, having held for 90 minutes, finally twisted and snapped. But they were slow now. 30 miles per hour. 20. The bomber groaned, lurched, and finally ground to a halt. Silence. Absolute, ringing silence. The props windmilled to a stop. The dust began to settle. Bragg slumped in his seat. His hands were cramping so hard they were locked into claws around the useless yoke. He looked at Engel. They were alive. Then, the panic set in. Bragg yelled, unbuckling his harness and scrambling out of the seat. "Waist, report. Tail, report. Waist is okay," Zook yelled back. "Sarpolis," Bragg screamed. No answer. Bragg sprinted back through the fuselage. He scrambled over the bomb bay catwalk, past the radio room, and into the waist. The scene stopped him cold. The rear of the aircraft was gone. The fuselage ended in a jagged maw of torn metal. The tail section had collapsed and was sitting on the runway, detached, twisted at a 45-degree angle, resting on its side like a dead whale. Bragg jumped down from the waist door, his boots hitting the Algerian sand. He ran toward the severed tail. The ambulance was already tearing across the airfield, siren wailing, medics hanging off the running boards. Bragg reached the tail section first. He grabbed the handle of the rear gunner's door and wrenched it open, expecting the worst, expecting to find Sarpolis crushed by the impact or broken by the collapse. Sam Sarpolis was sitting on his canvas stool. He was pale, shaking, and covered in dust. He looked up at Bragg, blinked, and slowly unbuckled his harness. "Lieutenant," Sarpolis said, his voice trembling but clear. "I think I'm done flying for today." The medics arrived a second later, breathless and carrying stretchers. They looked at the severed tail. They looked at the 16-foot gap in the fuselage. They looked at the single beam that had held it all together. One of the medics lowered his stretcher, staring at the aircraft in disbelief. "How?" he whispered. "How the hell is this possible?" Bragg looked up at the All-American. Standing on the ground, the damage was even more impossible than it had felt in the air. The plane looked like a skeleton. It shouldn't have flown. It certainly shouldn't have landed. "It wasn't us," Bragg said quietly, patting the torn aluminum skin of the fuselage. She just refused to quit. But as the adrenaline faded, the engineers from the 97th Bomb Group were already arriving with clipboards and cameras. They weren't looking for miracles. They were looking for data. And what they were about to find in the wreckage of the All-American would change the way American bombers were built forever. The flight was over. But the lesson was just beginning. That lesson wasn't found in a textbook. It was found in the twisted, tortured aluminum of the All-American's spine. When engineers from Boeing and the Army Air Force's Materiel Command arrived at Biskra to inspect the wreckage, they didn't just take photographs. They took measurements of the shear forces that the single remaining dorsal longeron had withstood. The numbers were mathematically offensive. The beam had carried nearly double its rated load for 90 minutes. By all conventional aerospace standards, the metal should have fatigued and snapped 10 minutes after the collision. The fact that it didn't force the military establishment to confront a brutal, uncomfortable truth about the two heavy bombers carrying the war to Germany, the B-17 Flying Fortress and its newer, sleeker rival, the B-24 Liberator. On paper, the consolidated B-24 Liberator was the superior machine. It was faster, it had a longer range, and it could carry a heavier bomb load than the B-17. The generals in Washington loved the B-24 because it was efficient. It was the logistics bomber, capable of flying deep into Europe and delivering more high explosives per gallon of fuel. But the men flying at 25,000 feet, men like Kendrick Bragg, knew something the generals didn't. The B-24 was built for performance. The B-17 was built for punishment. The survival of the All-American highlighted a fundamental difference in design philosophy. The B-24 utilized the Davis wing, a thin, high aspect ratio wing that was incredibly aerodynamic. To achieve this efficiency, the B-24 used a semi-monocoque fuselage design, where the outer aluminum skin bore a significant portion of the structural load. It was like an eggshell, incredibly strong, as long as it was intact. But if you cracked the shell, if a flak shell punched a hole in the side or a fighter slashed the skin, the structural integrity compromised catastrophically. The stress couldn't redistribute. The wing would fold. The tail would snap. Boeing, however, had designed the B-17 inches the mid-1000, 930 seconds, with what critics at the time called wasteful redundancy. They built the fuselage with heavy, closely spaced Z-frames and massive truss-style wing spars that passed through the fuselage. Think of the B-24 as a high-performance sports car. Fast, efficient, but fragile. Think of the B-17 as a suspension bridge. A bridge has thousands of redundant steel beams. You can cut a third of them, and the load simply finds a new path through the remaining steel. This bridge philosophy is exactly what saved Bragg's crew. When the Messerschmitts severed the All-Americans' control cables and bottom longerons, the load didn't cause the plane to unzip like a B-24 might have. Instead, the stress was instantly redistributed through the heavy circular frames to the dorsal longeron, the spine on the roof. The frames acted like fire breaks, stopping the structural failure from propagating further down the fuselage. The statistics bore this out in blood. Analysis of 8th Air Force combat losses showed a terrifying disparity. While the B-24 was shot down in higher numbers relative to sorties flown, the grim statistic was the ditching survival rate. If a B-17 was forced to ditch in the North Sea, the heavy frame usually kept the plane intact long enough for the crew to escape. Survival rates were nearly 80%. If a B-24 hit the water, the impact often shattered the efficient, lightweight fuselage. The plane would break apart instantly. Survival rates for B-24 ditchings were less than 40%. The All-American became the poster child for this inefficient durability. The photos of the severed tail didn't just circulate in mess halls. They landed on desks at the Pentagon. They validated a doctrine that would guide American military aviation for the next century: battle damage tolerance. Before this war, the primary goal of an aircraft designer was to make the plane fly well. After the All-American, the goal shifted: make the plane fly hurt. This shift in thinking had a ripple effect that extended far beyond World War II. When Boeing designed the B-29 Superfortress to bomb Japan, they incorporated the redundant electrical systems that had allowed Burbridge to fly the All-American with the autopilot. When the Air Force issued the requirements for the B-52 Stratofortress during the Cold War, they demanded multiple hydraulic backups and independent structural paths. You can even trace the lineage of the All-American to the modern A-10 Warthog, a tank-killing jet designed to fly with one engine, half a tail, and huge chunks of its wing missing. The DNA of that survivability, the refusal to surrender to physics, was forged over the Tunisian desert in 1943. But in 1943, the legacy wasn't about future jets. It was about economics. Not dollars and cents, but the economics of human life. The Army Air Forces realized that a bomber crew was a perishable, high-value asset. It took a year and $100,000 to train a pilot, navigator, and bombardier. If a wastefully over-engineered B-17 cost an extra $50,000 to build, but brought that crew home to fly another 25 missions, it was a bargain. The All-American was scrapped shortly after the investigation. The damage was too severe to repair. The engines were pulled, the instruments salvaged, and the miraculous dorsal longeron was cut up for aluminum scrap. But the crew, Bragg, Engel, Burbridge, Nunez, Sarpolis, and the rest, they didn't go to the scrapyard. They went back to war. They were transferred to other B-17 seconds, taking their experience, their skills, and their confidence back into the fight. That was the ultimate victory of the B-17 design. It didn't just drop bombs. It acted as an armored lifeboat in the sky. It allowed men to make mistakes, to face overwhelming odds, to suffer catastrophic damage, and still walk away. And while the All-American was turned into ingots, one piece of it remained immortal. Not a piece of metal, but a piece of film. The photograph taken by the B-17 flying alongside them, and the one taken on the ground at Biskra, became more than just documentation. They became the icon of the American war effort. They were proof that the machines built by Rosie the Riveter in Seattle factories were tougher than the fascism they were fighting. However, a photograph, no matter how powerful, is silent. It captures the result, but it misses the scream of the wind, the smell of hydraulic fluid, and the vibration of the yoke. It misses the human element. To truly understand the weight of what happened that day, we have to look at the final testament of the men themselves. The testament of Kendrick Bragg and his crew is defined not by what they said, but by what they didn't say. In the weeks following the miracle at Biskra, the photograph of the All-American was splashed across newspapers in the United States and pinned to bulletin boards in every bomber squadron in England. It became the ultimate propaganda tool, proof that American boys were flying invincible machines. But Bragg never gave interviews. He never wrote a book titled How I Cheated Death. When the 97th Bomb Group held its debriefing, Bragg's report was clinical, detached, and devoid of heroics. He listed the engine settings, the autopilot inputs, and the fuel consumption. He treated the impossible flight not as a miracle, but as a technical problem that had been solved. This stoicism was the hallmark of a generation that understood a grim reality. Survival was not an achievement. It was a prerequisite for the next mission. The All-American was scrapped, cut into pieces to feed the smelters that would build new planes. The crew was dispersed. They climbed into other B-17 seconds planes that looked identical to the one they had just broken and flew back into the flak over Tunis, over Sicily, over Italy. They didn't trust in luck. They trusted in the Z-frames. They trusted in the dorsal longeron. They trusted that if they did their job, the thousands of rivets hammered into place by women in Seattle would hold the line against the physics of destruction. And that trust was well placed. The B-17 didn't just win the war by destroying German industry. It won the war by preserving the morale of the men who had to fly into the teeth of the Luftwaffe. When a crew saw the All-American photo, the message wasn't "look at this damage." The message was, "You can come home." That image remains the enduring legacy of February 1st, 1943. It stands as the metal testament, a silent witness to the philosophy that machines should serve men, not the other way around. It proved that in the calculus of war, the most valuable component of a bomber isn't the Norden bomb sight or the Wright cyclone engine. It is the 10 men inside. And sometimes, preserving those 10 lives requires a machine to do the impossible. The All-American survived a mid-air collision, a severed tail, and a 90-minute battle with gravity. It proved that a fortress could fight the air itself and win. But the air is not the only enemy a pilot faces. There is a force more unforgiving than the wind, darker than the night, and far deadlier to a wounded aircraft than any German fighter: the ocean. The B-17 was built to survive the sky, but it was never meant to survive the sea. When a bomber hits the water, the rules of engineering change instantly. The frame that holds against 600 mile-per-hour winds can shatter like glass against a swell. Yet, there is one story of a bomber that defied even the crushing depths. A story of an aircraft that didn't just land on the water, but seemingly refused to die even after it sank. Next time, we will dive into the story of the only bomber to be flown onto the ocean floor and survive to tell the tale. If the story of Kendrick Bragg and the All-American made you appreciate the brilliant, stubborn engineering of the past, you need to hit that like button right now. It's a small click for you, but it tells the algorithm to prioritize history, to prioritize heroism, and to keep these stories from disappearing into the archives. And if you haven't subscribed yet, you are missing the briefing. We are building a library of the most technically detailed, narratively powerful military history on YouTube. From the impossible repairs to the tactical genius that changed the world, we are covering it all. Join the squadron. Subscribe, turn on notifications, and tell us in the comments, what is the most damaged vehicle you've ever seen make it home? I want to hear your stories. Until the next mission, keep your airspeed up.